Alright, welcome to the two-part series of measuring in units. We're in chemistry class, and eventually we're going to start measuring stuff and analyzing what those measurements mean. And if you don't think you measure up, remember you're the one doing the measuring. So this part we're going to talk about mass. And we say that mass is the amount of matter that's in an object. And you're like, Miss, you didn't tell us what matter was. And we say that matter is anything that has mass and takes up space. And you're like, what? Mass is matter, matter is mass, what are you talking about? And so for the purposes of our class, we can say that mass is how many particles or atoms are inside the object. So if we think of if you say the whole idea of you have a ton of feathers and you have a ton of bricks, which one weighs more? They're the same weight because you have a ton and a ton, but you're going to have way more feathers than you will in the brick. So you have a higher mass. If we say that feathers is the amount of stuff, we have a lot more feathers than we do brick for the same amount of weight. And we measure mass in grams. So I want you to take a look at this and tell me which one has the most mass. So if you picked A, because if we think of these as particles inside of the box, A has the most amount of objects in it, the most amount of matter in it, A has the most mass. And so mass and weight, they're kind of similar, but weight technically is influenced by gravity. So let's think about it this way. If you went to the moon, you still have the same amount of atoms in your body, but do you weigh the same? No, you feel much lighter in the moon. That's why they're buoyant, assuming that you believe that we went to the moon landing. But because we're not going to the moon in this class, if it helps you wrap your head around it, you can kind of think of mass as similar to weight and worry about the difference when you get to physics. And since it's similar to weight, we're going to use a scale. This particular scale is called a triple beam balance. And if we get to go back to class, this is the kind of scale you're going to be using in my class. And it's measured again in grams. And so you know the triple beam balance is balanced when you're at the level marker right here. When your balance marker is level with the 0, it's balanced. And so we have these movable masses that you move across with your object on the pan, and when your balance marker meets up with the line, then you're balanced, and that's what the mass is. So if we look at this one right here, based on where this ticker is, what's the mass displayed? If you said 1.1, you are correct, because each one of these little ticker marks, if we count them up, is 0.1. So our learning check, what is mass and what's the unit it's measured in? And how do you know when the triple beam balance is balanced? So mass is how much matter is in an object. It's measured in grams. So if you see an equation, anything that says grams, they're talking about mass. And you know your balance is balanced when your balance marker is at 0. Dat mass.